Hello everyone and welcome again to the Mathematecher channel. In today's video, we will focus on the study of the highest and the least values that a function can take, which are known as the maximum and the minimum of this function. As these values can be defined either within a range, which is a real interval between two fixed endpoints with no gaps, so we call them the local maximum or minimum of the function, or they're defined within the entire domain on which the function is defined, so we call them global maximum or minimum of this function. Now, as an example to illustrate our study, we are asked to study the variations of the function f, such that f(x) equals x cubed minus 3 times x squared plus 2 over the real closed interval that has the endpoints -2 and 3. Hence, we will start by the definition of our function over this interval. So obviously, as it is the case with every polynomial function, since our function f, which is a polynomial function, is defined and derivable on the set of the real numbers r, then our function f is defined and derivable over the closed interval -2 to 3, which is a subset of r. As for its derivative, f prime of x, it equals the derivative of x cubed minus 3 times x squared plus 2, which equals the derivative of x cubed, which is 3 times x to the power of 3 minus 1, minus 3 times the derivative of x squared, which is 2 times x to the power of 2 minus 1, plus the derivative of the number 2, which is obviously equal to 0. Hence f prime of x equals 3 times x squared minus 6 times x. Now let's find out the maximum and the minimum of our function f, and determine the sign of its derivative over our real closed interval, -2 to 3. To find the maximum and the minimum of our function f over the real closed interval -2 to 3, we will be looking for the values of the variable x for which its derivative f prime of x equals 0, and the images of these values of the variable x by the function f are the maximum and the minimum of the function f. So, as our derivative function f prime of x equals 3 times x squared minus 6 times x, then it equals 0 if, and only if, 3 times x squared minus 6 times x equals 0. So f prime of x equals 0, if, and only if, x equals 0, or 2. Which are the two roots of our second degree polynomial, 3 times x squared minus 6 times x. Now, as for every second degree polynomial, its sign is the same as the sign of the coefficient of its term of the highest power, which is in this case positive, if the variable x is out the interval of its roots, and opposite to the sign of the coefficient of its term of the highest power, so negative, if its variable x is within the interval of its roots, hence between 0 and 2, in this case. Therefore, if x belongs to the semi-closed interval, -2 to 0, union, the semi-closed interval, 2 to 3, then the derivative, f prime of x, is strictly positive, so the function f is increasing. Otherwise, if x belongs to the open interval 0 to 2, then the derivative f prime of x is strictly negative, so the function f is decreasing. Let's now trace the table of variation of our function f. So for the table of variation of our function f, the variable x varies in the closed interval -2 to 3, where the derivative f prime of x has a positive sign when x is between -2 and 0, so the function f increases from its minimum, f of -2, to reach its first maximum, f of 0, where its derivative f prime equals 0, then when its derivative become negative along the interval 0 to 2, it starts decreasing from f of 0 to reach its minimum, f of 2, where its derivative equals 0 again, then it increases again along the interval 2 to 3 where its derivative is a positive sign. Now let's summarize this little study, and see the graphical representation of our function f, along the interval -2 to 3. So, now that we have our table of variation, to draw the curve of our polynomial function f, we will calculate its value in the endpoints of the interval -2 to 3, and its value in its critical points, which are 0 and 2. So we have f of -2, that equals -18, and f of 0, that equals 2, and f of 2, that equals -2, and f of 3, that equals 2. Now, As our function f increases along the interval -2 to 0, and then decreases along the interval 0 to 2, then f of 0, that equals 2, is a maximum for the function f, within the interval -2 to 2. Then, as our function f decreases along the interval 0 to 2, and then increases along the interval 2 to 3, then f of 3, that equals 2, and which equals f of 0, is a maximum for the function f, within the interval 0 to 3. Then, as our function f decreases along the interval 0 to 2, and then increases along the interval 2 to 3, then f of 2, that equals -2, is a minimum for the function f, within the interval 0 to 3. After that, as our function f increases along the interval -2 to 0, and then decreases along the interval 0 to 2, then f of -2, that equals -18, which is lesser than f of 2, is a minimum for the function f, within the interval -2 to 2. Finally, as f of -2, that equals -18, is lesser than f of 2, that equals -2, then f of -2 is a minimum of the function f within the interval -2 to 3. And as f of 0, that equals 2, is equal to f of 3, then f of 0, is a maximum of the function f within the interval -2 to 3. And this is shown in the graphical representation of our function f. As always, thank you for watching. Consider to subscribe to the channel if this video was instructive for you. Give it a like and share it. And until the next one, have a great time.